Hello guys, this is Crux Academy. We're gonna solve some practical problems in chapter 1. So let's begin from the first one. So we are given this circuit and we are asked to calculate the power, the power supplied or absorbed, the power supplied or absorbed by each element. So the elements in the circuit are this one, this one, this one, and this one. So we have some independent source. We have a voltage source. There is also there is some passive, a kind of passive element, also current source. So we are asked to calculate the power supplies or absorbed by each element, P1, P2, P3, and P4. So in order to calculate P1, so from the previous session we know that power is the voltage times the voltage or the potential difference on that element times the current passing through that branch. So from elementary physics we know that the whole branch have the same current. The voltage on this P1, this element, the source provides 20 volt. So the current on this branch is 5 ampere. I1 is given by 5 ampere. There is something we need to consider when you calculate the power, that is the sign convention. We have learned on the previous parts or the theoretical part that when the current enter into the positive terminal of the element, the power is said to be absorbed, and that power is positive. So the power is positive. But when the current enter into in the negative terminal, the power will be dissipated. Power is dissipated or supplied. The power will be negative. So keeping this in mind, so P1 would be, as you see, the current flows clockwise. So it flows clockwise, entering into the negative terminal to the positive terminal. So the power would be, the current is depicted as -5, V is equal to 20 volt. 20 volt times the current is -5 ampere. So 100 minus 100 watt power is supplied. So for P2 is right here. So in this element, the current enters into the positive terminal to the negative terminal. So the voltage is given by 5 ampere. So 12 volt is we have given that 12 volt. The potential difference across this element is 12 volt. It's given. So the power would be 12 volt times plus 5, because from the sign convention the current enters through the positive terminal to the negative terminal. So 60 watts, the power is absorbed. So P3 is this one. So the voltage across the element is, the potential difference across the element is given by 8 volt, and the current I2 in this branch beginning from this point, this node, the current is given by I2 is 6 ampere, entering into the positive terminal to the negative. So the current will be positive from the sign convention. So the power is given by 8 volt times 6 ampere, which is 48 watt. It is positive. So power is absorbed by this element. The last one is this one. So for the last one, for P4, the voltage is not given. It's dependent current source. The amount is given by, the amount it provides is given by 0.2 of I1. 0.2 of I1. So I1 is 5 ampere. I1 is 5 ampere. So the 5 times 0.2. So the current will be 0.2 times I1. The voltage is parallel to this one. So from elementary physics, we know that current voltage is measured across, voltage is measured across the nodes, So the voltage across this is equal for both. They are perfectly parallel. They stood parallelly on the circuit. So parallel elements have the same voltage, the same potential difference. Both have the same potential difference. So this would be 8 volt. The amount of voltage on this source or element is 8 volt. So 8 volt times 0.1 of 0.2 of I1. This is the given current. I1 is 5. So this would be 1 minus 8 watt. This is because the direction of the current from the question, this is positive and this is negative. So from the convention, the current enter into the negative terminal and pass through the positive terminal. So power is supplied. So we learned that the summation of power must be 0, P1 plus P2 plus P3 plus P4 on the system, on the whole system. The summation of power must be 0. The power supplied must be equal to the power absorbed. That's the conservation law. So P1 is that must be 0. The summation must be 0. So minus 100 plus 60 plus 48 minus 8 watt is 0. Just you can check it. So let's come to the second. Let us come to the second example. So let's come to the second example. The circuit is this one. So we are asked to calculate the power absorbed by each component. So for P1, this component, we can see that the direction of the current is like this. The arrow directed to this. So the direction of the current is clockwise. So clockwise in this loop. So in this loop, in this branch. So the whole branch have the same current. So the voltage is given by 5 volt. So the current would be negative on this. From sign convention, the current on this component will be negative 5 volt times minus 9 ampere. So this will be 45 watt power is supplied by this component. The second is independent voltage source, which provides 2 volt, provides 2 volt. So P2 would be 2 volt times 9, which is 80 watt. The current would be positive in this case because the current enter into the positive terminal, to the negative. So the current in this case would be positive. So 80 watt of power is absorbed. For the first one, power is supplied. So for the third P3, As you see, the direction of the current shows that the current enters into the positive terminal to the negative. It is dependent voltage source. So current controlled voltage source is current controlled voltage source. To calculate the power P3, the voltage is simply given by the amount of voltage it provides given by 0.6 of I3. I3 is right here. It is the current on this branch. It is 5 ampere. It's given by 5 ampere. So 0.6 times 5. 0.6 times 5. The amount of the voltage is 0.6 times 5. The amount of current is simply 4 ampere entering into the positive terminal. It is the current will be positive. So 4 times 3, which will be 12 watt power is absorbed. In this one, power is positive. So for P4 is the component have 3 volt. 3 volt is the amount of the voltage is 3 voltage. It's parallel. It's perfectly parallel to this one. So both have the same voltage. It's already given 3 volt. 3 volt. The amount of current is 5 ampere. For P4, the direction of the current aligned with the edge. So the direction of the current enters into the positive terminal to the negative terminal. So the current will be positive. The current is given by 5 ampere. The voltage across the component is given by 3 volt. So the power is simply 3 volt times 5, which will be 15. Power is absorbed by this component. So the summation of the power must be 0. The power absorbed must be equal to the power dissipated. So P1, P2, P3, P4, their summation must be 0 minus 45 plus 18 plus 12 plus 15 must be 0. Otherwise, there must be a mistake on our calculation. So check that this is 0. So let's proceed to the next example, the third example. Okay, for third problem, we are asked to calculate the power absorbed by each component. So for P1, it's given that the current is 8 ampere and 9 volt. P2 is 9 volt and 2 ampere. P3 is the current is given by I. So the voltage on the potential difference on the component is across the component is 3 volt, and this source is for this force is constant supply of independent supply of 6 volt. So calculating P1, to calculate P1, so P1 is given by 9 volt. The current will be negative because it enters into the negative terminal to the positive terminal. So the current will be negative 9 volt times minus 8 ampere, which is 72 watt. For P2 2 ampere enters into the positive terminal. So 2 times 9, which is 18 watt. For P3 I times 3 volt. The power will be 3I. For P4 6 times. So both are positive because the direction of the current aligns with the polarity. So 6I. So the summation of the power must be, in order to find the value of I and calculate the amount of power on P3 and P4, we apply this the conservation of power. So the the whole system, the summation of the power on the whole system must be, the summation must be 0. So P1 minus 72 plus 18 plus 3i plus 6i must be 0. So calculating this, the value of I would be 6 ampere. Simple calculation. So 54 is equal to 9i. Simple calculation. I is equal to 6 ampere. So P3, from this, inserting the value of I into P3 and P4. So 3 times 6, P3 will be positive. Both are positive. From their polarities we can see that both are positive. So P3 is 18 watt and P4 is 36 watt. This is all of chapter 1. Thank you.